Well, last time we tried to clarify the distinction between analytic and synthetic, and we'll give some examples of that today. And we'll also look at Ayer's views on verifiability, that synthetic propositions have literal meaning or truth value only if they're in some sense verifiable. And then we'll look at the point raised last time, that is, whether the proposition that states the rule of verifiability is verifiable. That is, what type of proposition is it, and can it pass its own rule? Now, let's remind us of the difference between the two. To put it very simply, if someone says there's a yellow balloon floating in the hall, we could sit here and reason about the concept of a yellow balloon from now until eternity, and we wouldn't know whether it was there. The connection between the subject, the yellow balloon, and the predicate is floating in the hall has to be made synthetically by experience. That is, the two can't be connected by logic. I take it everyone can see that. I mean, that's true of any proposition about the external world. No false synthetic proposition violates logic. If I said Professor Flynn is not holding a pointer in his hand, that outrages your experience, does it not? But now it's true. In other words, there's nothing logically incoherent about it, whether it's true or false. It's just a question of outraging your experience if I say it's a false synthetic proposition. And that's why Ayer says that these propositions about the external world all have to at least be susceptible to the test of verifiability. Analytic propositions like a square has four sides, well, if you denied the predicate, you would do logical violence to the subject, wouldn't you? If you said a square has three sides, we'd say, well, you're not talking about a square anymore, you're talking about a triangle. You see the point? So there we say the connection between the subject and predicate is analytic, because a false analytic proposition always does violence to the concept of the subject. Everyone see that point? That in the one case, the connection between subject and predicate is vouched for by experience, and the other case, it's vouched for by logic. And that's why, of course, it has no applicability to the real world. To do that, it's the difference between pure and applied mathematics, isn't it? That is, pure mathematics, at least Euclidean geometry, shows that a triangle has 180 degrees. We saw that last time. But that's a proposition of pure mathematics. To say the triangles that waves of light make in the heavens have 180 degrees, that's a claim about the external universe, isn't it? And now it has to be verified, and in point of fact, it's falsified. That is, we now are good enough to measure these things. And here's the Earth, and there's one star, and there's another star. And let's connect them by light rays. Well, we find that when those stars are connected by light rays, the triangle formed bulges at the angles, doesn't it? So it has more than 180 degrees. And we know now that we live in curved space. That is, that's really the triangle on the surface of a sphere, isn't it? Imagine a sphere, and imagine three great circles making a triangle. Well, it would bulge at the angles like that. And so we know that, in point of fact, Euclidean geometry doesn't apply to the real world. It's an impeccable mathematical system. You know, within its axioms and postulates, all of the propositions are true.
When we're talking about synthetic statements, are we talking about absolute experience? As in experience if we had absolute knowledge of fact?
No, we're just saying if you make a claim about the real world, such as that there are 70 students in attendance today, the only way to verify that would be to count them, to see if I can see 70 students in front of me. If you say 7 times 10 equals 70, I don't have to look at anything, do I? I just have to know what numbers are and the rules of multiplication. So that would be an analytic proposition.
If I say the angle of that triangle, and I point, and I've got not that triangle, but say you drew a triangle on the board.
All right, let's do it. Well, that is a triangle. It's, however, a triangle on the surface of a sphere. Here's one on a plane surface.
Okay, and I point it out and I say those angles add up to 180 degrees.
And well, as long as we were just using that as a diagram, you would be analytically correct. I mean, I of course can't draw a perfect triangle, but if we took the concept of a Euclidean triangle, as I did last time, I could prove to you that given our concept of a triangle and given our definition of a degree, a triangle has to have 180 degrees.
But further than that, if you actually took a protractor and you measured it, and as far as your senses were able to see, it was 180 degrees.
That's right.
Now that might not be quite true because, you know, you don't have...
You're quite right. In other words, it can only have certitude as an analytic proposition. When it becomes a synthetic proposition, it can only have a high degree of probability. And that is true about that's the difference between pure mathematics and science, or applied mathematics. In pure mathematics, we get certitude at the price of not talking about the real world. When we want to extend our claims to the real world, we no longer get certitude, if only because you're always at the mercy of future evidence. That is, it is conceivable that when we got even better observations of the heavens, we would find that the heavens was not uniformly curved. You know, we might say all the triangles we see in the heavens have such and such degrees. And those degrees would be appropriate if the heavens was the sort of curved space we thought it was. But we might find that the curvature of the space actually was subtly different than we had known up at that. We might get better telescopes. And then we would have to say, no, Riemannian geometry, that's a particular kind of geometry that deals with curved space. We might say we have to have Riemannian plus geometry now to describe the universe. And you would never have a certain resting place, because how can you be certain that we won't get a more exact measurement in the future? Could be. You know, it could be that all of our measurements actually, you know, with the measurements that were possible in Ptolemy's day, there was no measurement which showed that it was fallacious to say that the sun was the center of the solar system. You know, he managed to put in enough epicycles that he could actually satisfy all the observations possible in his day. There were no telescopes then, were there? But later on we got observations, and it became quite clear that putting the sun at the center of the solar system could not satisfy all observations. And then it looked like Newton had satisfied all observations. But we got better and better measurements of the motions of Mercury, and they had a slight deviation from Newton. So we had to move on to Einstein, didn't we? And now it's claimed that while Einstein is very close perhaps to how the universe works, we may have to move on to string theory. Science never has a final resting place. You can always get better observations, can you not? Mathematics can have a final resting place. You can say within Euclidean geometry, this proposition is certainly true. But then you have to ask yourself, well, it's fine for laying out tennis courts, but does it really apply to the heavens? And that becomes a matter of observation.
Does that lack of certitude apply to all synthetic claims? I mean, if
Yes.
you say there's a yellow balloon in the hallway.
It applies to all synthetic claims except a very peculiar category, and that is claims about what is happening inside your own head at this moment. If you say, I am angry, and you're not lying, you presumably have conclusive verification of that. I mean, you know, if you're not lying, you're at this moment feeling anger. If you even say, I was angry yesterday, you might be mistaken. That is, you might have a poor memory, might you not? But there is a peculiar set of synthetic propositions. You'll note I have up there conclusive verifiability. They are peculiar. First person, present tense claims about what you are actually experiencing in the present. They can have, but note again, they don't apply to the real world, do they?
Sure.
You see, it's when propositions apply to the real world that their certainty is undermined. A purely subjective factual claim is synthetic, and it can be true because you're experiencing it. You could say, I'm thirsty. Well, you know, you should know. And if you're thirsty, aren't you? Let me see if you grasped the distinction between synthetic and analytic. What if I said cathedral square has 360 degrees? Would that be analytic or synthetic? Synthetic, because it's a claim about the real world, isn't it? And it's undoubtedly false. I mean, cathedral square isn't a perfect square, is it? What if I said either some ants are parasitic or none are? Or let me revise it. What if I said either at least some ants are parasitic or none are? Would that be analytic or synthetic? What do you think? Either at least some ants are parasitic or none are.
Is it analytic?
Right. I mean, the words are deceptive, aren't they? Because they're the words for familiar objects. But you could be saying either at least some Martians are blue or none are, couldn't you? Because the categories at least some and none exhaust all logical possibilities. If all Martians are blue, at least some are. If some Martians are blue, at least some are. If no Martians are blue, none are. So it's really an empty statement, isn't it? It's what we call a tautology. It pretends to be a statement about the real world, but it conveys no information about the real world, doesn't it? It doesn't tell us Martians exist. We would have to verify that. And if they existed, it wouldn't tell us what color they were, because it covers all the logical possibilities, you see. So always ask yourself, is this proposition informative about the external world? Don't be fooled by the words. If it's informative about the external world, then the truth test will have to be a test against experience. If it doesn't inform you about the external world, it may be true, but it's true only as a closed circle of definitions. Well, now let's get on to verifiability, because Ayer says he doesn't want to render empiricism ridiculous. We can conclusively verify propositions at this moment internal to your skulls, but that's not very significant. Even a present tense proposition such as Professor Flynn has a pointer in his hand, we might not all unanimously see it. The gentleman in back there may suffer from astigmatism, and he might see me without a pointer in my hand. It could be that you all came in high on LSD or something, and you're having hallucinations about pointers. That is, the only way to verify a claim about the external world would be to verify all of the consequences of that claim being true. Well, there's one consequence. You now can hear the pointer as well as see it. And if you came up here and I whacked you with it, you would feel it, wouldn't you? But there would be an infinite number of consequences, and we could never exhaust them all. But for all practical purposes, we could be convinced. That is, merely because there's an infinite universe of implications of my saying this exists, and we could never exhaust that infinite number of implications. After a while, we would say, well, we have pretty good evidence we're not hallucinating. You know, once when I was in the desert dying of thirst, I hallucinated an oasis, but when I ran forward, I got a mouthful of sand rather than a mouthful of water. Well, that was a pretty good indication that the proposition was false, wasn't it? But if you had got a mouthful of water, someone might say, oh, well, you were hallucinating tasting water. Well, if they were being that way about it, you could say, well, water has a certain density and sand has a certain density, and I'm going to weigh myself before and after. And when I weighed myself afterwards, I had the proper amount of weight of water added to my weight, blah, blah, blah. So eventually you could multiply test after test. And only an absurd person would say eventually that the proposition wasn't overwhelmingly probable.
And you're simply ignoring infinite regress by what you've just said there?
Well, yes, there's logically an infinite regress, and therefore we can never with certitude state a synthetic proposition. All we can do is add test on test on test. This is why Popper says that the propositions that we should rationally adhere to are those that we have striven very hard to falsify and have failed. We always have to have in the back of our mind that a falsifying experience might appear. But he would say, that's why we say things are only tentatively true. We merely mean they have survived falsification up to this point, you see. But there are a lot of propositions that haven't survived falsification up to this point. And a sane person will take the former more seriously than the latter. Now, direct verification, as you've seen, is never totally conclusive. Even though you all see me at this moment holding this pointer, a claim about the external world is never totally conclusive, but it can be very probable. Now, Ayer says, now we don't, however, want to be in the absurd position of saying that an empiricist can never make a statement about the past. So what if we want to make a claim about the external world in the past tense? Let's, to simplify things, make it a past that none of us observed, okay? That would be true of any past that occurred before any of us were born, wouldn't it? All right? But we can make it, it may be that none of us were out in front of this door at 7 a.m. this morning. I suspect none of us were. So there, I want to make a statement about the past before, at a time when none of us observed the past. So I'm not talking about memory, okay? Well, we can use indirect verification. Let us imagine that I state a proposition. At 7 a.m. this morning, in front of Burns 2, a tiger ran through the hall. Okay? Well, none of us were around. So are we left entirely at sea? No, what you do is you take several propositions that you already know to be true, and you take them in conjunction with the unknown proposition, and you deduce something you can directly verify that assumes the whole package. Now that sounds complicated, but it isn't. Let us say we know that this terrible circus that sometimes visits New Zealand, what is it, the Something Brothers Circus, was in the vicinity. So we all went to the circus 3 nights ago, and they had tigers in that circus, okay? And we know that there is no zoo in Dunedin like Auckland. So the only possible source of tigers would be the Ringling Brothers Circus. We also know that tigers don't wear galoshes, and it's been raining. So if a tiger ran from the surface to the Burns building, it would get its footprints muddy, wouldn't it? And tigers don't normally wipe their feet on mats. So if a tiger with muddy footprints ran through the hall, it would leave tiger tracks, wouldn't it? Well, now we can go out and look and see if there are tiger tracks there. And if there are tiger tracks there, that direct verification in the present produces an indirect verification that a tiger ran through the hall this morning before we arrived. Do you see how it works? That is, you take propositions known to be true. Tigers with muddy feet leave footprints. And you take them in conjunction with the proposition you want to test. A tiger ran through the hall this morning. Well, only if you put both of those propositions together would you expect footprints, would you? You know, the mere fact that tigers with muddy feet leave tracks, that wouldn't allow you to expect tracks in the hall. There had to be a tiger that actually ran through the hall to leave them, didn't it? So your prediction of what you can directly verify is logically not complete without the proposition being tested. And therefore, when you verify the proposition of the tracks in the hall, you indirectly verify the proposition that a tiger. Now there's, note again, it could never be certain. Students may have played a prank. That is, they may have gone to a taxidermist and got tiger feet, and they may have put mud on them, and they may have studied biology so well that they know exactly the distance apart that tigers that are running through the hall leave footprints. So that's where they'd probably fall down, wouldn't it? They'd have to know an awful lot to imitate a running tiger, and they'd left an imitation, you know. And then we would say, well, my heavens, you know, the proposition was 99% sure, but there is that one doubt. So again, it's overwhelmingly probable, but it's not conclusive. So we can deduce propositions about the past, as archaeologists do. They say if we find little round coins in the ground in a city that we carbon date of 10,000 years ago, it's very probable they had a money economy, you know, and they didn't just barter, right? So every proposition about the past is a matter of indirect verification. We know that people who have money usually use them as media of exchange. We'd have to be careful. They could be little medallions at first, couldn't they? But if we found hordes and hordes of them together and none of them had holes in to be strung, we'd be pretty sure they were money. And we would think, well, they must have gone beyond a barter economy. They must have had a medium of exchange, a currency. So you can see then we can have knowledge of the past through indirect verification. Then finally, there are propositions like, there are galaxies receding from our galaxy at faster than the speed of light. Now, we will never see those galaxies, will we? If they're receding from us faster than the speed of light, light from them will never get to us, will they? So we would have to infer their presence by the behavior of the furthest galaxies we can see. We would use the law of gravity, wouldn't we? We would say, well, the furthest galaxies we can see couldn't be moving in relation to us as they are unless something further on was pulling them out of course, you see. So we would use something like the law of gravity to infer their existence. Well, that would be indirect verification. But let us imagine that we had a proposition that there are galaxies so far beyond what we can see that they don't influence anything we can see. Okay, that's not a senseless proposition, but it is very unlikely we will ever have the conditions under which we can test it. We can all imagine the conditions. If we invented a telescope 80 times as powerful as anything we have at present, you know, we might pick up galaxies distant enough that we could make a stab at it. But you see the point. We can at least imagine how to test it. We are merely prevented by our limitations from actually testing it. When I was young, it was easy to give such a case, as I told you. It was the proposition there are mountains on the other side of the moon. And of course, we always seem the same face of the moon. So we know of no planet where the surface is perfectly smooth, do we? So it was a very sensible proposition, but we couldn't actually verify it. Today I can send a rocket around the moon with a camera, can't I? And today we can verify it. But at one time it was verifiable in theory, but not in practice. Everyone understand then the examples I've given that spell out the rule of verifiability. There are 4 different cases. Conclusive verification of experiences in your heads, which is a pretty trivial one. I mean, we would be interested in that if we were psychoanalyzing you. I might say to you, I don't think you're telling me the truth about what you're feeling at this moment, you know. So it could be of interest, but it's not about the external world, is it? And then we have direct verification, indirect verification, and things that are verifiable in theory but may not be verifiable in fact. Well, if everyone is clear on verification, now let's go back to the point the gentleman raised last time. Here we have a proposition. Synthetic propositions have truth value only if they are verifiable. Now that proposition is synthetic, isn't it? You can't sit around and establish its truth by mulling over logic. That is, I know if you denied it, I can't see that you would say anything logically incoherent. If you deny that a square has 4 sides, you've done violence to the concept of a square. But if you say, I think some synthetic propositions have truth value, even though they are not verifiable, I don't see that you've used words in a nonsensical way.
But because they're not really referring to the real world. They're referring to
Exactly.
abstract concept. Doesn't that mean then that they're an analytical? That it's an analytical statement? And
But let's see what it really is. I'll bet you I can convince you that it's synthetic rather than analytic in the following way. Would you consider the rules of baseball to be synthetic or analytic propositions?
Analytic.
Well, they're analytic perhaps if you take them in toto. That is, you can always say, these spell out what it is to play a baseball game. Normally, we would say, well, it's not like a square has 4 sides, because we have actually revised these rules over time. Now, you can always say, every time you've revised the rules, you've invented a new game. You know. In fact, they have revised the rules of baseball, haven't they? I mean, baseball evolved from cricket, and at a certain point, it did become a new game. But let's say that I made a minor change in the rules, and I said, when the catcher catches a tipped third strike, you're not out. At present, if I had 2 strikes and I tip a ball with my bat and the catcher catches it, I'm declared out. And we might say that's a little unfair. We want to give the batter a break. You know, when you tip a foul and the catcher catches it, it's no longer out. Now, again, you can always say that each time you're giving an analytic definition of what baseball is, and now it's a new game. We would call it baseball plus.
Why would you need to say that? I mean, you don't call a square a different square every time. You don't call a triangle a different triangle every time it has slightly different.
Well, I'm trying to make plausible your assertion that it's an analytic system. You see. I mean, many people would say no. It's a descriptive system in the sense that if someone said to you, what's the difference between baseball and cricket? You would have to not just say, let's sit down and reason logically together. We would have to go to 2 different rule books and see what the difference was. Now, let's imagine for the moment that they are synthetic. Is it reasonable to say that they ought to be testable? Because you cannot test by reference to the activity, the rules for an activity. That is, it's perfectly reasonable for me to say, I struck out, isn't it? It's not reasonable for me to say, well, how come the rules of baseball can't strike out? You see, or it's perfectly reasonable for me to say, you checkmated me in chess. It's not reasonable for me to say, how do you checkmate the rules of chess? That is, the rules for a system of behavior are never subject to themselves. Now, that's what we're really asking with the rule of verifiability. We're saying it sets up a set of rules for testing the truth of propositions. How come it can't pass its own rules? Now, there's still you have to take a way out here. Just as we would with chess, we would say, well, the rules of chess are not the same as playing chess. They set the ground rules for how you can end a chess game. There are only 3 ways to end a chess game. One player mates the other, there's a draw, or there's a stalemate. And you'd say, to talk about can we stalemate the rules of chess is absurd. They set up the rules. They don't apply to themselves. Now, what Ayer really should have done is that he should have rephrased what he said. He should have said, factual propositions and propositions of cause and effect have truth value only if they are verifiable. Now, that would get him out of the logical dilemma, wouldn't it? Because the proposition that says that is neither a fact nor a cause-effect proposition. And therefore, we have made plain that it's a proposition about the rules for truth testing facts and cause and effects. But it is an epistemological proposition. And therefore, we now see crystal clear that there is no reason why it should pass its own test. You know, the way Ayer puts it, he just says synthetic propositions. Well, epistemological propositions are synthetic. So it makes his test self-referential. It's as if he says all propositions that are synthetic must be verifiable, and that seems to include the proposition he's just stated. But he should limit his claim. He should say propositions that assert the existence of something, or propositions that assert that something else causes effects on something else in the real world. They are vacuous and less testable. But the proposition I've just stated is not a cause-effect proposition, and it's not a claim about facts. It's a claim, it's a set of rules about how we assign truth value to either facts or causes. Just as the rules of baseball are a set of rules about how we assign either striking out or getting a home run to a ball player. But they are not ball players. You know, there we don't make the confusion, do we? We never confuse the rules of baseball with the activity that they are rules about. So we can get Ayer out of the logical dilemma by saying he should make it crystal clear that the rule of verifiability sets rules that apply only to factual propositions and cause-effect propositions, not epistemological propositions. But that opens a new problem. If we cannot say that the rule of verifiability is valid because it's verifiable, we now have to say, why is it valid? We can't take a shortcut, can we? And now we have to discuss deep philosophy. We have to say, how do we choose one epistemology or theory of truth over another? What Ayer is really doing is saying, I'm an empiricist. And if you are an empiricist, you will only accept things as existent or having causal potency if they are testable against sense experience. But you might say, well, I have an epistemology that includes faith. And on the basis of faith, I posit the existence of something like a transcendental God. And therefore, what you say is true of an empiricist, but it's not true of a believing Christian. Or you might be a Kantian. Kant said that the universe we live in is peculiar. He said, out there is something, the thing in itself, but it's totally unknowable. I think I might have used an example for you once before. Any of you attended 3D films? And you put on the spectacles, didn't you? And before you put on the spectacles, you saw the thing in itself, which was a movie screen that was two-dimensional with wavy lines on it, out of focus. Then you put on the spectacles and you see it organized clearly in terms of 3 dimensions, don't you? But imagine you could never take the spectacles off. Then you would never know what the thing in itself was like. It could be 16 dimensionals. I mean, since you can take the spectacles off, you can see that it's 2, correct? But if you had the spectacles welded on, all you would know is that the noumena, when seen through your spectacles, is organized 3-dimensionally. You see Kant's point. So he said, Ayer is mistaken. We have reason to believe that there's an external material universe out there, but it's simply unknowable. All we can know is the phenomenal universe that we see structured through our spectacles. I take it, if I had pink spectacles on, all of you would look pink. And if I couldn't take them off, I would never know what your true coloring was, would I? Because you would all be pink. You've got to be. That's the spectacles I've got. So Kant believed not in, well, he may have believed in God, but let's put that aside. He's at least positing the existence of an entity beyond experience, namely this noumenal world that we convert into a phenomenal world through viewing it with certain spectacles. Then there was Plato. When you studied Plato, Plato thought that he could make a case for an externally existing world of forms, did he not? And he had certain arguments that he thought were valid. So how do we decide? We have cured Ayer from the notion that he is incoherent. In other words, empiricism is not incoherent. It's like any other epistemology. It sets up rules for truth finding. And of course the propositions that set up the rules can't pass the rules. As we saw from baseball, that's crazy. The rules that tell you a strikeout, what a strikeout is, can't strike out. The rules that tell you what checkmate is can't be checkmated. But empiricism at present seems no better off than non-imperial epistemologies that try and tell you that there are other ways of knowing that work. Now, I would say that the only way to decide between epistemologies is which has the fewest absurdities. I say that because empiricism does have one absurdity, and that is a problem we've referred to before, the problem of induction. I take it all of empirical science is aimed at predicting the future, isn't it? And it does so on the basis of past observations. And yet we're struck by an absurdity that has been called since Hume the problem of induction. And that is, why do we have the slightest reason to think that the future will resemble the past? I take it you can't use deductive logic to establish any factual proposition, not even that there's a red balloon floating in the hall. So you can hardly use logic to establish what the future will be like, can you? No one can get into a time machine and go to look at the future. That would be cheating anyway, because for the person in the time machine, it's no longer the future. And we never observe necessary connections between events. If I observed a necessary connection between my letting this pointer go and its falling, then one experience would be enough, wouldn't it? That is, if we actually saw necessary connections between events, but all you see is a repeated sequence of events. The next time I let it go, it might miraculously balance forever. But to give you a more convincing illustration, imagine I brought a pre-industrial person in this room who was unaware of magnetism. And let's imagine that I put some iron filings on that table and passed a magnet over it, and he saw the iron filings leap up to the magnet. Now, if he had seen a necessary connection between the two events, one experience would be enough, wouldn't it? But given his background of experience, he would suspect trickery. He would think, I'll bet that little thing they call a magnet has glue on it. And I'll bet that there is some trick here, that hidden to me, there's part of this table that's a lever that flips the iron filings up. And when they get to the magnet, the glue holds them. That would be a perfectly reasonable thing, wouldn't it? Because a magnet would seem to him like magic, right? I mean, this can't attract iron filings. My hand can't attract iron filings. What is this strange thing that apparently can pull something towards it without touching it? I mean, any object I influence, I have to touch. Any object that this influences, it has to touch. And yet he's seen something which seems to grab things at a distance and pull them to him. Now, if we could see a necessary connection between those events, one experience would be enough, wouldn't it? You'd have seen the necessary connection. The mere fact that if we were a pre-industrial person, we would want repeated sequences shows that we didn't see a necessary connection. After a while, he would be convinced. He would look under the thing and find no lever. And if he were sophisticated, he might think maybe those iron filings are light enough that a wind could carry them in the air. But he might verify that they're too heavy for that. And then he might rub the magnet and say, well, I can't find any glue. And then he would say, try it again. I still don't believe it. And maybe after 10 or 12 tries, he would say, okay, I accept. There are some material objects that are peculiar in some way that I can't understand, that they can attract other objects at a distance. So Hume pointed out that all of our experience about the past is like that. No one has ever observed a necessary connection between two events. All we have had is repeated experiences of sequences of events, and after we have enough of those, we assume a necessary connection. You know, after the dog has touched the radiator once and got burnt, it may not shy away. After it's touched it 3 or 4 times and has got burnt every time, it will assume a connection. But remember, the 5th time the radiator might be turned off, mightn't it? And then the dog, reasoning inductively, would be mistaken. We're all in the position of that dog. For all we know, tomorrow the radiator might be turned off. That is, up to this moment, every observation of the heavens we have made has shown that the planets attract one another inversely as the distance squared. But you have no reason whatsoever to reject that at the next moment it won't be inversely as the distance cubed, except your blind faith that there's a continuity between past and future.
And there's some things that do have this necessary connection. Instinct, for example. If you know that if you have this feeling of hunger, and if you eat something, you will not feel that connection anymore.
How do you know that tomorrow, if you eat something, you won't feel even hungrier?
Because that would
Because it would violate the laws of nature. But that's Hume's point, that all of the law. What do we have here?
Survey?
Oh, this is the survey. Yes, put it down there. That all of the laws of nature are really just summaries of our belief in repeated sequences of experiences. You know, time after time after time, all of our measures confirm that planets attract one another inversely as the distance squared. But there's no logic in it, it's just a brute observation.
Well, what about something like if I decide that I want to lift my hand, and I decide that I'm going to lift my hand rises up.
And tomorrow it may not. In other words, but it's even worse than that. If you're looking at me at this moment, Hume would say you have no reason to even assume I will continue my personal identity in the next instant. In the next instant, I could turn into a kangaroo. Now, I see that we're running out of time. Now, what's going to happen is, I'll get the surveys here?
Just,
Huh?
Uni 101.
Oh, here, I'll get the surveys. They're in my office. And Carla wanted to get a survey, not of the course, but of her as a lecturer and me as a lecturer. So you'll have 2 separate surveys. And are you the one who's going to put them in an envelope and mail them over?
No, I'm the one that does the Uni 101 survey, so it actually
Yeah.
has, you're both on it, on the list.
That's right. And so
it's like,
who puts them in, I'm not supposed to touch them. Who puts them in the envelope?
Well, I take them back to the OUSA office.
That's right.
Put them into
Okay.
the computer and then
Okay, well, let me get the surveys.
You don't have to leave. It's really...
Well, I have to leave to get them.
No, I have them.
Well, you don't have enough of them.
No, this is just the one for OUSI. So this is just.
Oh, that's the OUSA one.
Yeah, and the other one's.
Okay. Oh, I didn't realize. Okay, well, give that out. Because you threw me off guard because the other one was supposed to be on Tuesday.
Oh, okay. Yeah.
And I thought, how come it's moved up from Tuesday?
Sorry for that.
All right, well, you can give them those. So I can go right on lecturing, can't I?
Yeah, sure.
All right. Well, I'll go right on lecturing. So let's come back to your point. Here we have, if everything you are saying assumes a continuity between past and future. Now, you can always say, aha, I've got you. Whenever I have predicted the future on the basis of the past, it's worked. But that, of course, is a past experience, isn't it? So you're begging the question. That is, of course, predicting the future on the basis of the past has always worked in the past. Whenever you ate the food, you were less hungry, weren't you? And whenever you woke up, you hadn't turned into a petunia. You were still what you were. So, of course, but that's assuming what you're trying to prove. What you're saying is, whatever has worked about prediction in the past will continue to work about prediction into the future.
Well, my point is that a child doesn't need to try out, hitting themselves on the head to get rid of hunger or throwing their leg up in the air to get rid of hunger. There is an innate knowledge that eating reduces hunger. I mean, it's an innate knowledge that, you know, you see.
Well, the child doesn't know that eating will keep it from starving. It just knows it wants food. I mean, no infant really knows anything about nutrition, not even the basic fact that nutrition is necessary to sustain life. All it knows is that it has an itch, and that itch needs to be scratched, doesn't it? You know, that it has a hunger, and only if you put a bottle in its mouth does it stop feeling that itch. But this is, again, Hume would say you've got to play the game. Every time you open your mouth, you're sneaking in the assumption that what has been true about infants to this moment will continue to be true about infants. You know, here we've got the infant, and let's say the infant feels hunger, and we put a bottle in its mouth, and infant suddenly starts spitting the bottle out. It turns out that they've all turned into sadists, you know, who enjoy hunger. You know, all the rules are changed over here.
What if all matter is deterministic, so that it's no longer
Well, Hume, of course, is fatal to naive determinism. That is, naive determinism assumes necessary connections. And he is saying that sort of determinism has to go. Now, that doesn't mean determinism as an alternative to free will goes, does it? Because we could say, look, in order to discuss determinism versus free will, we have to put aside the problem of induction. You know, let's not talk about the future. We can talk about whether what you did yesterday was free or determined, can't we? You see, so rather than talking about free will in future terms, we could say, have you ever had a free choice? And then we would have to say, well, in the past, the laws of psychology held, and I happen to believe that I can show, as Freud did in the psychopathology of everyday life, he tried to show, very unconvincingly, that even his most trivial actions were dictated by his unconscious mind. And so we could have an intelligent discussion as to whether that was really true. But we would qualify it by saying we're discussing whether past decisions were true. Even if there were true decisions in the past, free decisions, that wouldn't guarantee that we wouldn't all turn into clocks in the next instant. And if we all turned into clocks in the next instant, that would be the end of free will, wouldn't it?
So is that basically saying that anything is, it's almost like saying anything is logically possible from one moment to the next?
Yes, because logic cannot set boundaries on the future, but it's more than that. It's saying also nothing is more probable the next. As Russell summarized it, he said the problem of induction really means that your expectation that when you bite into a poached egg it will remain a poached egg is no more rational than a lunatic's assumption that it will turn into a snake. Because we can't use probability to get out of Hume's dilemma, because probability assumes that the past gives us a sample of instances that are relevant to the jar of the future. That is, you wouldn't think I was sampling jar A if I chose all of the things out of jar B, would you? And you see, he's drawn a line between the jar of the past and the jar of the future. Sometimes students misunderstand. They say, oh, well, we can't be absolutely certain about the future. Of course not. We all know that. But on the basis of past experience, we can make probable assertions about the future. But if the beans in the jar of the past have no relationship to the beans in the jar of the future, the past isn't sampling the future, is it? It's just sampling itself.
But then, from all past experiences, which has shown the past to be a good indicator, can't we infer?
Let's put it logically. Here's the proposition that is under dispute. The proposition that is under dispute is whether the past has a non-contingent connection with the future. That is, it's anything other than totally contingent. So does the past have a non-contingent relationship with the future? Anything other than a random connection to the future? And here we have a proposition. In the past, The past has always been a good predictor of the future. Now, you would have to deny this as your major premise to make that a minor premise. That is, the major premise has to be there is a non-contingent connection between past and future. Before your assertion, there has always in the past been a non-contingent between the two, leads you to a conclusion to the syllogism. So you see, what you're really doing is that you're taking the minor premise of a syllogism and not supplying the necessary major premise to reach your conclusion. If the past is up for grabs, the fact that the past in the past has always been a good predictor of the future is just begging the question. Over here.
Well, in that case, Hume must also deny the past, because if...
Exactly. This is the next step. The next step is that how do you know that 10 seconds ago the universe didn't pop into existence with all of our memories of a fictitious past intact? This was used by religious people to explain geology. That is, there was a bishop who said, the Bible says the universe started 4,004 years ago, and geology says it's much older. But how do we know that God didn't just make the universe 4,000 years ago, looking as if it had a past history? Of course, this makes God sort of like an unscrupulous antique dealer, doesn't it? that he creates...
Who still believes the Earth is flat when he's taken up in a helicopter.
Oh, that's a different thing. Well, if he thinks the Earth will become flat in the next moment, he's on solid ground. If he thinks in the present tense, though, when he's actually observing, he could say the Earth was flat 10 seconds ago and turned round only then, with us having, the Earth was flat 10 seconds ago, and it turned round now, and we have fictitious memories that it was flat before now. So you're quite right. This is the terrible thing about Hume's dilemma. Once you realize that it puts the future up for grabs, you then have to say, if you think about it carefully, if things can pop into existence, be shape-changing, I call it the law of spontaneity. If you can have totally spontaneous events, you can have no confidence about either past or future. Let's go from that point next time.